machine learning is AI and and ML put together to help make computers smarter, to help us understand more and get more insights out of data than we have in the past. So what things are easy for humans but hard to code? So that's sort of like the premise. How should we think about this? All right. So I always like to start off asking people a question, and that is, how many of you out there can tell the difference between a puppy and a muffin? I know it sounds really funny, right? And looking at these pictures, of course, as a human, it's probably pretty easy for you to tell the difference between a puppy and a muffin. However, if you were to get a computer program to do the same thing, you probably have to draw up, some rules and guidelines to sort of help the code figure things out. So let's say you know how to analyze images, writing computer code. Maybe, in an image of a puppy, you may be looking for eyes and maybe a nose and ears. And maybe for the muffin, it may look like a giant volcano with colorful paper around it, things like that, right? So those are some basic rules that you could probably code to help your program tell the difference between a puppy and a muffin. So what I'm going to do now is I'm going to change the pictures and ask the same question again, which is, how do you know how to tell the difference between a puppy and a muffin? Okay, notice just by changing images, I've almost changed the question on you, right? But I didn't, right? The question is still the same. However, it's a little bit more difficult now. The rules that we defined may no longer work, like searching for eyes and a nose and maybe ears. Maybe those things will give you a lot of false positives or false negatives, right? So rules is not going to be enough. So we need a little bit more than just rules, and that is experience. So at sort of its very core, machine learning is rules as well as experience. Okay, so how does your brain do it? So over, as you've grown up as a child to becoming an adult, you've seen enough cats and you've seen enough dogs where certain signals go through your mind that tells you this is a cat or this is a dog. And everybody goes through this. This is how you think. But in order to make sort of a computer think this way, we have to sort of simulate how the mind works, and that is developing all these layers where you're sort of like triggering. Part of it's going, I'm pretty sure this is a cat, and then you keep on looking at it, and then you develop more signals, and then eventually you come up with sort of like a decision as to what that object is at to a certain percentage, right? So that's how a human does it. But then once you have that vocabulary and that database in your head, that knowledge base of what is a cat, what is a dog, when you're given a new photo like this one, all right, you have to kind of like go back in your mind and start, using those signals that you've developed over the years to sort of tell you, is this a cat or is it a dog? Okay, cat and dog, this might be more difficult than a puppy and a muffin, but the thing is still similar, right? So you're trying to figure out what all these signals are that eventually lead you to that conclusion. And so this is sort of like kind of like a high level summary of how machine learning works. So AI is sort of like a large subset that basically talks about how we can sort of simulate any kind of human intelligence using code. And then machine learning is sort of like a smaller subset of that, where you're actually making the code learn from experience instead of writing out explicit rules like we just described. And then on top of that, we have deep learning, which is where you're trying to make the code itself get even better or smarter. So it's even, it's like self-learning. Okay, so this is sort of like a kind of like the onion, if you were to sort of like peel it back.